This is Honors Pre-Calculus Review, Exam Review. Question number 71. Recall that if we are multiplying these two together, that the r's are multiplied together, so 3 times 4 is 12, but the angles are added. So this would be 2 pi over 6, which is pi over 3 with a common denominator. This will give me 12 CIS 3 pi over 6, which is the same as pi over 2, divided by 6 CIS pi over 4. I divide the r, and I will get 2, but I subtract the angles. I'm going to get a common denominator of 2 pi over 4 minus pi over 4. This will give me 2 CIS pi over 4. Number 72, I'm taking to a power. Recall that I take the r to that power, but I change the angles by multiplication. This would be 81 CIS 220 degrees. Number 73, I'm determining the coordinates of r and theta that are solutions. I'm going to set the two equations equal to each other. 2 cosine theta is equal to 1 minus 3 cosine squared of theta. Since I have a power of 2, I'm going to set this equation equal to 0 by adding 3 cosine squared of theta to the other side. And subtracting a 1 from both sides and factoring. When I solve by setting each one equal to 0, I find that the cosine of theta for this one is 1/3, which is a calculator question, and the cosine of theta equals -1, which I know from the unit circle is 180 degrees. By using my calculator, I can see that this will be quadrant 1, which is positive, but also quadrant 4, the cosine is positive. So I end up with angle measures for the cosine of theta equaling 1/3 of 70.5 degrees and also 289.5 degrees. I also had the 180 degrees here. I need to find my r by substituting back in. I'll substitute in the 70 degrees into the first equation. This would be 2 cosine of 70.5 degrees. Then I get 1/3. So this would be 2 times 1/3, or 2/3. So this would give me an answer of 2/3, 70.5 degrees, 2/3, 289.5 degrees. When I substitute r 180 degrees, I have -2. So I also have a solution of -2, 180 degrees. Number 74, I'll set the two equations equal to each other. This is sine of theta equals sine of 2 theta. I'm going to replace the sine of 2 theta with its identity, which is 2 sine theta cosine theta. set the equation equal to 0. By subtracting a sine theta. I'm going to factor a sine theta out. Set each factor equal to 0. And in this particular case, I'm asked to answer in terms of radians. So my answer here would be pi or 0. Made a mistake. I'm going to fix that. It should be 2 cosine of theta minus 1. Setting 2 cosine of theta minus 1 equal to 0. I find that the cosine of theta is equal to 1/2. This would be quadrants 1 and 4, where the positive cosine would be. This would be pi over 3 and 5 pi over 3. Substituting back into the first equation, which is easier, the sine of pi is equal to 0, so my r is 0. The sine of pi over 3 is equal to root 3 over 2. The sine of 5 pi over 3 is equal to negative root 3 over 2. My solutions are 0, pi, 0, 0. Root 3 over 2 pi over 3. Negative root 3 over 2, 5 pi over 3. Number 75. I have a series. I need to represent it using summation notation. I can see that these are powers of 2. This would be 2 to the 3rd, 2 to the 4th, 2 to the 5th, 2 to the 6th. I'm going to begin at 1. Since there's a dot, 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 I'm going to infinity. I'm doing powers of 2, but I'm beginning with power of 3, so I'm going to substitute in n plus 2 to begin this series at 8. Number 76, again using summation notation, I'm going to begin at 1. There are 1, 2, 3, 4, 5, 6, 7 terms. I notice that the common difference now is 4. I'm going to come up with my explicit equation, which is a sub n equals the first term, which is a sub 1, which is 11, plus n minus 1 times the common difference of 4. I get an explicit equation of 4n plus 7 when I distribute and simplify. So I'm going to substitute it into my summation of 4n plus 7.